All right, so this is now the cybersecurity panel session. We have three panelists up here today, and we're going to be talking about cybersecurity, how to move the needle for EV charging infrastructure. So with that, oh, wrong clicker. There we go. All right, so first off, Brandon Harris, here to my right. And a microphone. Thank you. Technology Manager for Cybersecurity from the Joint Office of Energy and Transportation, and he's supporting from the Volpe National Transportation System Center. So thank you, Brendan, for being here. Next is Mike Slowinske, Engineering Director from UL Solutions. Thank you, Mike. And last but not least is Jordan Smith from Southern California Edison in the Grid Technology Innovation Center. I have one or two slides very briefly. So I'm going to introduce this panel session. I will then hand it off to each of the three panelists to have a 5 to 10 minute discussion each of what they would like to talk about, what is their focus areas and whatnot. And then we will open it up for a 45 minute or so Q&A session. Hopefully the audience, you will be thinking about questions to engage with the panel because the panelists are here to provide a wealth of information. If it is silent, I do have a few backup questions prepared, but they're probably going to be boring. So put your thinking caps on, jump around because it's leap year, get that caffeine and energy flowing and think up some good questions. So the focus for today is how best for industry to improve cybersecurity and cyber physical security from across the entire electrified transportation ecosystem. Because this ecosystem is comprised of many different systems and subsystems from many different manufacturers, whether it's vehicles, chargers, energy management systems, communication networks, authorization, you name it. It's this whole ecosystem. And if all of those subsystems are working correctly and are secured, we have a good day. But even if there's only one or two of these systems or subsystems that are unsecure, it could be the downfall for the entire ecosystem of electrified transportation because one crack in the system could open up additional vulnerabilities and additional impacts. So my question generally for this panel is what steps can we take to ensure a safe and robust transition from where we are now to a unified electrified transportation ecosystem that is safe, secure, and resilient? Here we go. I will hand the microphone. Well, you already have a microphone. I will hand it over to Brendan. So the clicker for advancing slides, the laptop will not advance slides.
Got it. Yeah. Okay. Thanks, Barney. So hi, everyone. My name is Brendan Harris. As Barney mentioned, I'm with the Joint Office of Energy and Transportation. Quick show of hands, how many people here are familiar with the Joint Office of Energy and Transportation? All right, we've done a good job seeing as we're fairly recent. Our mission is to accelerate an electrified transportation system that is affordable, convenient, equitable, reliable, and safe. Our vision is a future where anyone can choose to ride or drive electric. My job is to say, what about the future where everyone can hack electric? So you'll notice that we have kind of a unique position in terms of where we live in the federal R&D ecosystem or the deployment ecosystem. Many traditional R&D projects take place at this very low technology readiness level that you see in the, where you see traditional Fed R&D. It's usually a waterfall strategy, long duration project. Failure is informative, not considered an issue. And success tends to be fairly incremental. The Joint Office, on the other hand, is taking a very agile approach. We are only in existence for another 2 years or so. The timeline of our projects tends to be months or quarters. This is a very large one-time investment, so we consider failure to be fairly unacceptable. And we'd like to see, the success of our projects be fairly transformative. So in terms of most federal R&D spending, it's at these lower TRL levels, like I mentioned. Meanwhile, we are really focused on the deployment and the rollout of the national electric vehicle infrastructure. kind of some guiding principles for what the Joint Office is all about, trying to be the center of gravity for coordinating federal EV charging cybersecurity efforts, collaborating proactively with the builders, deployers, and maintainers of that infrastructure. We really want to match the urgency and agility we're expecting from industry, execute our projects quickly with results that are useful immediately. Bottom line is bring our friends to achieve impactful results on aggressive timelines. Some recent and ongoing efforts that I'll go into a little more detail in the following slides are to produce guidance for our grant recipients. So most of the Joint Office efforts are to facilitate the build out of the national electric vehicle infrastructure through our state partners. And so we want to make sure that those state partners are making smart procurement decisions with these one-time funds. So to assist with that, we've generated some sample procurement language. We're looking into how EVSE cybersecurity incidents fit into the larger incident reporting framework that exists at the federal and state level. We're trying to analyze some of the complex multi-stakeholder barriers that exist to aid industry. So that includes the theory and practice of plug-in charge PKI infrastructure. We've heard a lot about that throughout the different offices. Again, our focus is really on the implementers and what we can do to move the bar now. We're also looking at doing some field testing and form best practices. So understand where industry is at, develop analytical tools that can move the bar on those. And finally, we also have a charging ecosystem security working group that we use to coordinate product cybersecurity experts from all over. So to go into a little more detail of about our projects, we have a sample procurement language for NEVI grants. This was developed by Pacific Northwest National Laboratory. Since the states are the early implementers of these federal EV charging investments, we want to make sure that they have a unified set of sample language they can use when they're purchasing or putting together their RFPs to include all the best practices. These have been published on the Joint Office website since last summer. You can go and check them out if you'd like, but the basic framework here is that there's a cybersecurity program that is held up by 5 technical areas. I won't read them all off the slide here, but each one of them has 1 or 2 clauses related to them. The idea being that the state should have confidence when they are purchasing this equipment that certain cybersecurity requirements, which are in the federal law, 680, CFR 680, I forget which section, but either way, there's a whole legal backdrop for all of this, which the procurement language was meant to facilitate the states in meeting these guidelines. We're also in the middle of looking into, as I mentioned, an incident reporting framework. So making sure that our stakeholders are prepared to respond to potential cyber incidents, understanding what are incident reporting processes, making sure that they're meeting any requirements that are within the law, because there are some reporting requirements, some of which are allocated to the state, some of which are passed on to the EVSE providers. And really understanding how, again, they can integrate with existing processes at the federal and state levels. We're going to develop and validate this approach with the stakeholders and develop, good guidance for them in the coming months. We're also analyzing the NEVI standards and how public key infrastructure exists within those standards, make sure that there aren't any latent systemic vulnerabilities that are within these standards that are required by federal law. And if there are any red flags that come up, that we do our best to inform those standards organizations such that they can remediate those more systemic vulnerabilities. And then additionally, understanding that many times PKI vulnerabilities manifest in specific implementations in other words, that the theory can be limited by the actual implementation of these things. We're doing some no-fault stress testing of the OEM preferred implementations of PKI within ISO 15118, OCPP, and OCPI, which are the big 3 required standards for all federally funded electric vehicle infrastructure. We have our first event coming up here in April. It's going to be focused on 15118, and we have a second event, that will be coming up, I believe, in Q3, focused on OCPP. That second event may change depending on, pending the outcome of the first event. And that's being done by NREL. Additionally, we want to understand, what's the state of the existing build out. There is a rip and replace mandate out there also, or a potential federal funding available to enhance or replace existing infrastructure. We also want to make sure that the NEVI deployments are improving the the baseline of security. So we are analyzing the state of practice through security assessment. This is a white box assessment. We have an industry partner that we're doing this with, and develop risk mitigation best practices for the deployers and the operators of the existing build out. So there'll be two sets of best practices, one for improving your existing build out and one for the states to use. Again, say, are you following these best practices which were developed? So again, think about it as an attacker and then develop, maybe more of a blue team approach to it. The final thing we're doing is coordinating the charging ecosystem through this security working group. We had our first meeting back in October, had about 50 to 75 representatives from both government and industry. The membership is really geared towards product security engineers, so senior cybersecurity experts with a role in product cybersecurity, or federal program managers who have cybersecurity in their portfolio and EVs in their portfolio, and then use that convening authority to identify and really come up with basically the punch list of what do we need to do in the next, what are some 6-month things that we can do to really move the needle on cybersecurity. So we have that list. It's informing all of the next round of joint office cybersecurity activities. And we'll be using that to again, inform our next batch of activities. So hopefully the next time you hear me speak, I'll have some new slides to talk about new projects that we're working on. There are some opportunities to get involved in this. If you're interested in joining the Charging Security Working Group, you can come up and talk to me. Or again, if you're an owner or operator of VVSE, a commercial or public fleet owner operator, if you're a power generation or transmission equipment manufacturer or operator, please reach out to me. If you're interested in participating in the PKI adversarial events, you can reach out to Tony and Ryan, who I might ask to just give a little wave to the audience. And if you're interested in participating in the incident reporting framework, I might ask you to talk to Tom Carroll, who you may recognize from the last talk. But Tom, can you give a little wave? All right. So that's what the joint office is up to. Really looking forward to discussing more with the rest of our panel members and discussing what we can do to move the needle. So thanks.
Thank you, Brendan. I will check to see. Yep. The clicker works. The laptop is just display only. So clicking on the laptop only. Thank you.
All right. Hello, everybody. My name is Mike Slowinske. Thanks for having me today. I work for UL. I am the engineering director for our principal engineering team. We work with manufacturers who develop new technology. And when there is no standard and there are no requirements, we help write those requirements. We work with manufacturers to understand the hazards and come up with a draft of what the requirements should be, and then hand that over to our standards and engagement side of UL that works with industry groups and technical committees to get those published into a consensus standard. So I think we all know that there's issues with the rollout of renewable energy, that cyber risk is increasing along with the rollout of renewables, because every piece of equipment is internet connected and talking to each other. We don't have to think about safety from an electrical hardware standpoint. When you walk in this room and plug something in, you don't have to worry about, when I plug it in, is it going to start a fire? Is it going to overload the receptacle or the conductors in the wall? Because the receptacle has been tested, the conductors have been tested. Even if they are overloaded, there's a circuit breaker that's been tested, and it's supposed to trip when it should trip. All that's tested in our lab. We make sure that everything is electrically safe. We make sure that there's not a fire hazard because the manufacturer's plastic supplier is giving them plastic that is flammable. We find that the plastic is flammable in our lab because we generate a nice big fire in our lab and tell the manufacturer, please go back to the drawing board. So we don't have to think about that because it all works together, because just as everything works together as a system, the codes and standards also work together as a system. There are standards at the product level and at the system level, and there are installation codes to make sure that everything is installed correctly. And then there's also enforcement of the codes to make sure that everything, usually in a building like this, when this building is under construction, the last step before opening the building is that an electrical or a fire marshal will, and some kind of an inspector will come through and make sure all the equipment has the certifications that it's supposed to, and everything was installed in accordance with codes. For cybersecurity, we're really just at the beginning of developing that ecosystem of how standards and codes and enforcement can improve overall security of the entire system. We've got component manufacturers need to demonstrate security. They need to somehow understand what the minimum requirements are to show that their products are secure, cyber secure, and safe. And system integrators, when they're purchasing those components, they also want to make sure that, just like that, an end product manufacturer buying plastic from a plastic supplier, system integrators need to make sure that all the components and all the nodes of an intercommunicating system are not vulnerable, thus making the overall system vulnerable. So they want to purchase products that are secure, integrate properly with secure systems, and not integrate with insecure systems, and demonstrate compliance. And again, just to illustrate the problem, these are images, the next two slides are straight out of ISO 15118. They just illustrate that for EV charging, you've got all of these different points that a bad actor could try to penetrate and disrupt the system. From UL standpoint, we care about cybersecurity for cybersecurity's sake, but we're not just talking about payment security. If somebody pays to use the EV charger and they steal my data, that's one problem. But there's also the problem of, could a bad actor or a foreign government hack into the system and tell, like in the last presentation, I think Tom said that, or maybe it was Barney said that, what if you put a -1 in front of something, and now instead of charging, you're discharging? What if you do that for every EV charger in Denver at the same time and tell them all to discharge at the same time? What happens to our electrical infrastructure then? So it's not just a cybersecurity problem, it's an electrical hardware problem as well, to make sure that cybersecurity isn't a method to cause serious damage and disruption to our electrical grid. And this is another image from the standard, again, just to show all the different pieces of the system and all the different places where bad actors could potentially disrupt things. So codes and standards are important. They need to work together to foster a safe system. These are some of the standards that are related to EV charger cybersecurity. We've got SAE 21434. That's really for the vehicle, not for the charger. UL 2941 is a standard. I'll talk a little bit more about that effort, because that was an effort that we did together with NREL and DOE for inverter-based resources and distributed energy resources cybersecurity, but it doesn't cover EV charging. There's other standards that in other industries that maybe have some requirements that are relevant for consumer, IoT, industrial controls, power management, but again, not specific to EV charging. There is the NIST informational report, cybersecurity framework for electric vehicle fast charging infrastructure, but that is an informative report. It's not a standard with test requirements and pass-fail criteria. We also have the electrical codes. Just to give you an analogy to something that's being done in other types of products, just recently, the 2023 National Electrical Code included cybersecurity requirements for the first time. So this provides those electrical inspectors who go around and inspect new construction something to point to when they want to say, I'm not accepting this installation because it doesn't include cybersecurity as part of the design. Section 110.3 is just a general requirement. It's kind of a foot in the door that says cybersecurity is one of the considerations that inspectors can consider when they are accepting installations. And then there's a much more specific requirement for circuit breakers, that if a circuit breaker is remotely adjustable, there are some circuit breakers that connect to the internet and you can update the firmware remotely. Those type of circuit breakers must have cybersecurity built in. And it does also reference certain standards, ISA 62443, the UL 2900 series, or the NIST framework as the basis for the requirements to demonstrate that your circuit breaker is safe with regard to cybersecurity. And then as evidence of compliance, it also requires a certificate from a NRTL, that's nationally recognized testing laboratory. That's a designation that OSHA gives us as a test lab and other labs like UL, or an ISA security compliance certificate, or the manufacturer's self-declaration is also permitted at this time. It doesn't require that you have to go to a third-party lab. The manufacturer can declare that they meet it, but they need to know what they're doing. So with regard to UL 2941, this was published just last year. This was a joint effort by NREL and UL at the request of Department of Energy to write some requirements, some testable requirements with pass-fail criteria, because it was the same problem that I just showed for electric vehicle charging cybersecurity. There's standards that are relevant, related, or there's guides and informative reports, and but they're not mandatory. They're not written in a way that can show pass and fail, good or bad. And so we wrote this, and now that is under consideration by a technical committee. My colleague Jennifer there is the chair of the committee. If you're interested in participating or joining, you can see her. But we took the draft that was written by just UL and NREL input, and now we have a wider industry group made up of manufacturers, utilities, inspection authorities, and so on, to try to make that a better and more industry accepted document. These are some of the things just from the table of contents that it addresses: cryptography, data management, monitoring, logging, etc. I'm not going to go into all those, but just to give you an idea of the scope of what the standard covers. And I mentioned that there's a technical committee that's formed now. If the technical committee votes in favor of the standard, right now there are some revisions and updates being considered, but if the technical committee votes in favor of that standard, then it will become an American national standard. And also would like to have that referenced in the codes so that inspectors look for a cyber evaluation and not just an electrical safety evaluation when DER are being installed. Some of the proposals that are being discussed right now are, additional tests, expansion of the scope. Should there be a risk-based approach, or should there be hard requirements? We don't want the requirements to be too specific, because we don't want a list for hackers to use to say, oh, here's the list of what they did to comply. I just have to defeat all these. So we need it to be a little bit nebulous while still providing the required level of security, and then addressing remote updates as well. So the same kind of effort could be done for EV charging. I think that's one of the things I'd like to get feedback on as part of the discussion is such a standard needed for EV charging? Or should we work together with ISO or IEC or SAE in one of those efforts? But we need to close the loop and ensure that there are standards for the products, there are codes for the installation, and there's also enforcement that look for the right certification or installation or declaration to make sure that these types of products at the EV charging is cyber secure to prevent, as I mentioned before, not just stealing somebody's data, but really causing serious damage to our electrical infrastructure and the electrical grid. So thanks, and I'll hand it off.
Thank you, Mike. Next up is Jordan.
All right, now that's my one slide. I don't need the clicker. So yeah, I won't touch anything.
Thank you.
Yeah, I didn't bring any slides today. For those of you who've seen my 60-slide V2G presentation, it's probably a good thing. Promised Barney keep it brief, succinct here, but that was great to hear. I'm definitely interested in joining that committee. We started talking about this topic with Lee Slezak and the US Drive, the grid integration technical team, environment, this need with EV charging. So it's great to see a lot of these advancements come into place now. Actually, it's kind of difficult. I learned just recently, it's kind of difficult to make cybersecurity slides. So I'm learning here as well from Barney and Tom and panelists here, Tony. Some hot off the press news. It's now gone. We put out our public notice. March 27th, we'll be holding a public workshop where we'll be launching our first 5 EPIC 4. So EPIC is the funding mechanism, ratepayer funding mechanism for RD&D programs, and there are 4 administrators, Southern California Edison being one. And so this is the 4th tranche. So EPIC 4, we're launching our first 5 EPIC 4 projects on March 27th. And so if anybody wants the link to attend that public workshop and you didn't get it, just let me know. One of the 5 projects that we're launching is a quantum computer networking project, which is very interesting. So I am the chief engineer for our EPIC program in this launch. And so I was working with the team putting together these initial project concepts. So we came to putting together our presentation for our cyber quantum networking project. It was interesting. So I'm taking notes here from my cybersecurity experts on cyber slides. So I've been with Southern California Edison for 27 years. And so I'm hoping to bring maybe a little bit of that user operator perspective to cybersecurity of EV charging here. So I was part of the team that put together a lot of history with Southern California Edison and electric vehicles, EV charging. I was part of the team that stood up and ran the EV Technical Center, which was one of the early efforts to just establish electric vehicles and EV batteries and chargers as sort of a commercial prospect. And so we ended that activity in about 2017 and taking some pride in some success, we think, in helping to make EVs commercial reality and no longer needing to do that kind of core work. So I'll talk a bit about, try to bring us up to a bit of history and kind of bring us up to where we are today and all the things that are coming together here, which are nice to see. Back in 2015 or so, we launched our Charge Ready program. And so this was a very unique thing, and it was a pioneering thing for Southern California Edison. This was basically an evolution of sort of utility operating principles where the various commissions enacted programs that enabled utilities to build charging infrastructure on the customer side of the meter. So traditionally, we stay on our side of the electrical system, and then the customer builds out their side. And there's different codes and jurisdictions. Won't get into all that. But our Charge Ready program was basically an authorization to do charging infrastructure work on the customer side of things, which we build, own, and operate. And that's a very unique thing. And so we had to figure out how to do all that. And we were, if you go look at the news, we were kind of the first to launch those systems and get them running and with pretty good success. So one of the things we had to do was we had to we had to approve the charging infrastructure that was to then be connected to our infrastructure and to be used. And so this didn't exist. So we had to set up a way to approve that charging equipment, the EVSEs, DC, AC chargers. And so we had to develop a list of requirements. And then it was a very intensive process. We actually then took applications from vendors, and we brought every single system into our lab and tested every single charger, every single charger. Very resource intensive, and we knew we couldn't do it forever. But that was really, kind of groundbreaking. And so my team basically developed what became known as the APL. We kind of invented the APL. You may have heard this. It's become a popular idea, popular mechanism. In fact, other utilities, use our APL. Originally, it stood for Approved Package List. And the way we put it together, there were certain package elements that came together to form a system. There was the hardware, the operator of the hardware or network service provider, whatever you may call it. And then there's sort of the service elements, the installers, that type of thing. And so we did a full system evaluation, very labor resource intensive, and approved these systems. And some of them didn't approve. And so we learned a lot there. When you do these vendor engagements and you have your list of requirements and the vendors come back and, they just say yes to everything, right? Yeah, we meet all that stuff. But then, you get the things in the lab, and then you may find out that they may not meet all of those things. And so these are, and I think you mentioned the sort of the enforcement mechanism. So suddenly we became the enforcement mechanism. And so we try not to have specialized standards and requirements. We try to, work with the standards development organizations so that they're, universal industry standards, and they have a certification mark. That's what utilities want to do. We don't want to, we ultimately don't want to have these specialized resource intensive methods. So we're looking for, for stamps and third-party certifications. Not a lot of these areas have those set up. I'll give one example that's not cybersecurity. We have a long history, actually, which has been successful working with the auto industry on power quality. And so there's an SAE power quality standard that SCE has co-chaired since the beginning. And so that's part of our qualifications for that equipment. And so we enforce that. It's otherwise not enforced by AHJs or otherwise. And so cybersecurity was one area in our list of qualifications where there was a lot lacking there, these types of sort of third-party certifiable standards. And so we work with our commission, our Public Utilities Commission, thoroughly throughout all this process. And as a result of this identification of this sort of gap, if you will, the commission ordered Southern California Edison to execute some work in EV charging cybersecurity on behalf of all of the California investor-owned utilities. So we developed a plan, and I can say that we've actually launched this now. We've signed a contract with a partner to carry out this evaluation, which is fairly comprehensive, and it's going to be looking at well, it's going to start from kind of where we are today. Do an assessment of the equipment that's out there and what's the state of that equipment and their providers, and then look at what others have done and are doing, including the things we're talking about here, and then look at standards that could be then implemented and how they would be implemented. So that's now launched. Maybe I should explain a little bit about the sort of the utility, as we call it, our program, the Charge Ready program. So this utility infrastructure beyond the meter that utilities now own and operate and manage. So obviously not all installations are those types of installations. So customers that build their own, without the utility, they deal with the electric code and the authorities to permit on that side of the meter. And so we're not approving that charging equipment. But in the case of our owned and operated system, we have that level of that sort of the extended posture there. And so we have, we've incorporated methods to manage that part of the system. So generally on the customer side of the meter, the codes are different. There's local authorities that enforce those codes. SCE, other utility, I mean, from the utility perspective, there's sort of broad overarching authority in the areas of safety. And so although the authorities enforce the code on the customer side and the permitting and that type of thing, if there are safety issues, the utility maintains broad authority to provide service or not provide service. And so that kind of gets at the core of things, and interesting connections with cybersecurity. And so, you know, I will mention that, well, first of all, on the safety side, so if there are any electrical hazards that our utility workers find, they'll disconnect. Any utility does this today. They'll disconnect your service. They'll turn off your power, and then they'll give you a correction notice. You'll have to fix it. So I've actually been involved with one of these myself. I found a safety defect at a site, and you know, I had their service removed until they corrected the problem. So in this sort of EV charging space, if there are safety issues, that's what we're going to do generally. If somebody, you know, something blows up or catches on fire, or somebody gets shocked, we're going to turn off service to that site until it gets remediated. And so we saw this as really not a great customer engagement, not a great customer engagement perspective. And so we try to avoid that with these types of activities. Well, what's evolving now with cybersecurity is sort of a similar perspective from our position, in that if a customer their EV charging system is hacked and they've lost control of that, similarly, we would be likely to remove service to that customer until that's resolved. So these things, as you can see, are really getting elevated as electric transportation systems grow. And we estimate we've got about 500,000 EVs in our territory right now. We're doing a lot of projects. So just wanted to make that connection. I think I'll stop there and we'll go to Barney and the Q&A, but hopefully that sets the stage a little bit for the conversation with the three of us.
Yes, very much so. Thank you, Jordan. So now we do have plenty of time for a lot of questions for the panelists. So I'd first like to open up the room to any questions. And I do have, that's not the right, and I do have backup slides too. So be it. But are there any questions in the room for any of the panelists? I'll just leave it. No. Yeah, Tony, here, use the mic, please.
For Michael, the PV 2941 IBR inverter-based resources standard, what would it take to take what you put together for that and apply it to EVSE systems? What's the process? How long might it take so that we'd have something usable for the industry?
Well, yeah, thanks. So to adapt that from DER to EV charging, a lot of the requirements would be identical. You know, password management and things, it doesn't change, but because there's different communication protocols, I think we just need a couple of people who are probably in this room with that expertise to say what are the unique vulnerabilities for EV charging because of the different protocols they use. And so I think it wouldn't take that long because we do have a base to work from. It would be months, not years.
All right, any other, yep, here you go. Thank you.
This question's for Brendan. So I know the Volpe Center works across much of DOT. Are there analogies from other part of DOT's kind of cybersecurity that would provide insight here? Two that I was thinking about was connected vehicle communication and something from the kind of FAA, given their huge network and all the issues there.
I'm sorry, I couldn't really hear the question. Could you repeat it?
Are there analogies from other parts of DOT that could provide insight here that we can kind of leverage?
Oh, absolutely. So before I came onto the joint office, I was looking at transportation, critical infrastructure control systems, and the automotive industry, control systems within the automotive environment. And that industry really matured since 2009 when some of the first academic research on automotive cybersecurity started coming out to today. They have some of the same, maybe like structural issues where there's a complex like supplier integrator relationship. These are legacy systems that are going to exist for a number of years after they're deployed in the field. And I think there's a tremendous amount that we can leverage both from what the automotive industry has done in the last 10, 15 years, and also what the intelligent transportation systems domain has done. So that being kind of the highway infrastructure side, and they've really matured their understanding of cybersecurity as well. So I think that there's a coming integration between EVSE and intelligent transportation systems and grid operation. So I think there's really a wealth of information out there, and it's really about tailoring it to the unique constraints within the the electric vehicle charging space. And even going beyond that, one of the things that we're really trying to do is to define like a common architecture that we can point to. This is one of the things that came out of that meeting back in October, and use that. And it seems like that's exactly the kind of thing that UL wants to then leverage some of the work that UL's been doing. So short answer, yes, there's a lot going on within DOT that we can leverage. Thank you.
Oh, another question. Here we go.
Yeah, hi. So a lot of times we as humans tend to overemphasize low priority risks and not understand higher priority threats, right? So in the early days of vehicle cybersecurity, targeted attacks against single vehicles were popularized in the media, but aren't really kind of realistic threats to anyone more than any other threat in our day-to-day life. So I want to know, like, from your perspectives, are we focusing on the right threats and risks in terms of investments in cybersecurity for EVSE and EVCI? Or are we, I don't want to say, are we sort of underemphasizing, our unknown unknowns? Are we, or are we doing the right things to establish something like the CMMC, so cybersecurity maturity models, to make sure that the sort of practice of cybersecurity is properly considering priorities?
Sure. So a number of the projects that I mentioned today are being done in partnership with other DOE offices, such as the Cybersecurity and Energy Security Emergency Response Office. So the field testing we're doing is actually part of a much larger project called Supply Chain Enumeration Analysis and Risk Mitigation, Cyber Scream. So I think that that's really looking at some of those broader threats, in the ICS space related to EV charging. So I think we do have a broad base we're basing it on. I'll say, at least from the joint office perspective, we really are just focused on the EV charging infrastructure itself, like that last mile, and that there's a number of other DOE programs that are out there that are looking at some of these broader, more systemic issues.
Yeah, add a little bit. I mean, in utility activity, cybersecurity is overlaying everything we do, and it's not really, doesn't get publicized. So we do, to a limited extent in venues like this, talk about these things, but internally we can't, I like to say, we can't buy pencils without cybersecurity. But it kind of overlays everything we do, and especially, our demonstration projects that we do. And a lot of this is behind the scenes that gets taken care of in contracting. And really what we're trying to do is to kind of move this into more of a standard certification activity to help us there. We get involved with contracting with vendors, and this can take, months and tons of money. And the terms, well, the terms themselves, so for example, vendors may say, well, I really want to be a vendor for you. So help me prepare, what do I have to do? Can you give me your requirements and standards? Well, we've got extensive cybersecurity requirements, but we can't give them to you. They're secret. But you'll see them when we get into contracting, and then, you'll have to comply with them. And a lot of this is based on risk and liability and who's responsible and who pays and these types of things. And, to the extent that we can better prepare through the use of standards and improving the posture of those partners or suppliers or vendors to the utility is going to really help us. And if you look at the magnitude of the work that we have to do for electrification, it's enormous. And you just look at you look at the sort of the standard copper, iron, civil builds that has to take place. And what we're trying to do in sort of the technical department is overlay on that sort of a controls system that would, mitigate or make more use out of the infrastructure. And so how are we, which we spend every day on, how do we do that? How do we merge those together and make those elements functional and useful? And that's where, cybersecurity ends up being one of the main things that we're working with. So we're going to have, millions of EVs out there, and they're connected and they're useful as resources. And we can do smart charge management and manage their impact such that it reduces the impact on the grid and everything else that we have to build and provide. But before we can get to the point where we can rely on those as assets to do that type of thing, they have to be secure and reliable. Otherwise, I have to build like I do today, which is when a customer wants service, whatever, 2 megawatts, they get 2 megawatts, 24/7, 365. In the future, that needs to be a dynamic allocation, but that's not going to work until we have, secure systems. So that hopefully that helps illustrate. And I get your point about sort of the scale and things, and maybe it seems like it's going a little too far, but we're really looking ahead into the future. We're not looking at individual cars. We're looking at millions of cars and millions of chargers, and how those can be, useful assets on the system. Otherwise, we're in big trouble if you look at what needs to be built out.
Thanks. Yeah, I'm seeing a big shift right now in the thought process where, nobody was coming to UL asking us to do a cybersecurity certification or validation. And so we weren't writing standards because nobody was asking us to do it. And the DOE, saw that was a problem, and let's solve the chicken and the egg and just say, let's write a standard. And now there's a standard, and now manufacturers can use that. And then, the burden that's falling on you as a utility right now to do all that validation yourself, in the future, maybe you can just rely on a certification. And so we're just at the beginning of that, and it needs to be refined, and the requirements need to be refined a lot. But at least we have a starting point. For EV charging, I think it's the same thing. There's a chicken and egg, and somebody just has to go first, and then that'll lay the foundation. So right now, maybe we're worried about small things because that's what we can address. But we do need to look, as you are, what's it going to be like 15, 20 years from now, and how do we address those big problems?
All right. Oh, yep. Question. Here we go.
So we maintain a vetted product list at EPRI, and we try to assess things. And one of the things we always try to do is find standards to reference, which makes things easy, right? Get the certificate.
And so just thoughts about this, because if you safety certify a product, the wires are sized properly, insulation, those sorts of things. And that's pretty static, right? That product goes out in the world and we know it's safe because of those engineering inputs to that. But you certify something as cyber secure, and it kind of feels like, okay, that's maybe at that moment it was, but you know, it's like a diligence thing, right? That somebody's going to be finding holes. And so I guess one concern I have is, okay, I've got the certification. Does that mean it's totally bulletproof forevermore? And probably not. So just thoughts about that. Like you get a certification process, but how do we do that diligence that comes after that?
So diligence about in the future and future updates. Yeah, I think that it's going to have to be unlike hardware, you can install it and kind of forget about it. Software, you've got to keep updating it and stay one step ahead all the time. And the test tools have to stay one step ahead all the time. But I guess one thing that gives me hope is all the presentations we saw yesterday and this morning about all of the work that the national labs are doing to develop these test tools and figure out how to stay one step ahead. You know, there is a lot of great work being done. And so we just need to continue that and keep investing in it.
So there's embedded requirements on when you must do upgrades, how the upgrades must be done, how the firmware, how, if you have remote upgrades, how that has to be done. So that's baked into the requirements. Does that help? Yeah, software's it's a whole different animal.
Maybe I'll tie this into one of the previous questions we had, which is what can we learn from transportation? And I think a friend from UL mentioned it earlier, but ISO SAE 21434 is really about creating a secure systems engineering process. That it's definitely not a silver bullet and everything. There's certainly issues with that standard, but the approach of requiring or having a process for engineering something securely and having a plan for product maintenance that includes cybersecurity management, secure updates, all of that is something that I think we can port into this space fairly easily. I've used that standard in a number of kind of odd applications, and I do think that it can certainly extend beyond just the automotive specific flair that it has. So I think, and it's an open problem in cybersecurity. How do you ensure security forever? And I don't know that the three of us on the stage can necessarily answer that very difficult problem right now, but I would say there are folks that do work on that and finding and porting that solution and these approaches to maintain the security of something over time is absolutely something we're going to have to do with EVSE as with any connected infrastructure asset.
Yeah, it's a great question. And so, John helped us with setting up and executing the APL in the beginning. So sort of it's our inside plant, on the question there. But one of the things that we built into the APL process is an enforcement mechanism, because we knew we could only do so much with the evaluations and the assessments, and the initial compliance would be assured. But then when they're out and deployed in the field, what happens then? And so we basically built in an enforcement mechanism, which is still there. And basically it relies on the field performance. If anything happens in the field with our contracts, we reserve the right to disqualify anybody. And so this was sort of this idea of continuing surveillance. And we had methods set up where we would be able to detect problems, customer complaints, customers call us and system's not working. So it was an attempt at doing that kind of long-term surveillance. But I think the UL and other NRTLs that do certifications, they usually have some surveillance element there. Cybersecurity, and that's where there's a departure with sort of the safety standards and cybersecurity principles, because it's not just the hardware, it's a system. And so when you put that UL stamp on there for safety, 2202 or 2594, with the cybersecurity stamp on there, it has to mean more. And there has to be some mechanism that enforces that. So our lab, our EV Tech Center lab, was ISO 9001 registered. And so if anybody's done ISO 9001, you know what I'm talking about there. That is a system registration where you have certification of your operations, and there are audits and surveillance, and there's a process there to make sure that your operations are consistent with your procedures and the ISO mark. And so similarly, I think in cybersecurity, you're going to need some hardware component, and you're going to need some system operations level component. And still there's questions in my head on how that all comes together and you maintain surveillance. Like when does somebody stop complying? If you go out of compliance in your ISO system, is that some type of certificate that would provide some notice to others that that's no longer compliant? I think that's a big question mark that we've got to maybe work on together.
Yeah, I can add some detail to that. As a nationally recognized testing laboratory from OSHA, one of the requirements of OSHA, of UL as a test lab, is that we go out 4 times per year minimum to the factories that are producing UL certified equipment and verify that the products coming off the production line are the same as the products that we originally tested. And that way we make sure that manufacturers have not, either could be on purpose or could be inadvertently, changed their production. And that could be because their supplier gave them a bad part, or it could be that the engineering team, wanted to save money and they switched to a different part, but they forgot to tell UL about it, and that somehow affects the safety. We have a mechanism to visit manufacturing facilities and make sure that those parts have not changed. And with regard to software, we tie that down to software revision levels and do spot checks of the code to make sure that nothing has changed in critical sections of the code. But there's, I think, a lot more that could be done, and a lot more that could maybe be done to automate that check to make sure that things that are tested and certified to be secure remain secure, and that any updates enhance safety rather than for some reason detract from it.
Maybe add one more point. So we have advanced metering infrastructure. We're working on next generation advanced metering infrastructure that's going to give us a lot more capabilities for detection, for anomaly detection. And so we're working on all those requirements and what we're going to build into that next generation. We certainly have some capabilities today. There's some latency issues, but we can do remote disconnect if we need to. We can interrupt 200 amps in most meters. But that's sort of last straw stuff I was talking about before. But you asked about enforcement. That's kind of last straw. We open up the meter. But in future capabilities, we'll have these abilities to connect with and communicate with devices right there at the edge. And at that point, we expect to have much more robust methods to detect anomalies with systems and whether they've been compromised. But that's all in the works.
Thank you. Any quick?
Thank you. Jordan, this one's for you. You mentioned you have a 2 megawatt load coming on. You have to build to that because you can't count on them adjusting off. Do you have programs now where you have the credit, where you can count on a load doing what you want it to do now I'm not talking about like an interruptible load, but something where you can have a program through smart thermostats, where you can count on them, shedding. And if not, when do you think you can may be able to have that with electric vehicles? Like this will be robust enough that you can count on it.
Yeah, it's a great question. That's kind of core of some of the things we're working on right now. So, there's a distinction sort of between DR, like you mentioned, the programmable thermostats and that type of thing, which is great. But sort of from a DR perspective, you're looking at like generation, transmission issues, capacity issues. You're not looking at like circuit capacity issues. And so although we may have connected DR, I think we have over 1,500 megawatts of DR programs. All of the wires and the copper and iron and everything serving that customer serves 24/7 for everybody. So the future that I kind of hinted at before was sort of a dynamic. We're not even allowed to do this from a regulatory perspective today, to have this, what I talked about, and I live in the R&D world, to talk about this sort of dynamic capacity. We've got a pilot, if you kind of follow the news, that we got approval recently to launch, and along with a new UL standard, looking at something that we call LCMS systems, load control management systems, which we've got a pilot, and we're just starting to test these theories that we could have sort of a dynamic. We're looking at several sort of phases in there, but one of the things we're looking at first is sort of a capped system. So an example here, whatever the 2 megawatt example, somebody comes in and they're bringing in whatever 2 megawatts of truck chargers or something like that. Well, I've only got one available on the circuit, and but they may not be bringing in all 2 megawatts all at once right off the bat, and so maybe, which I can't do today, maybe I can give them service for 1 megawatt with the appropriate control system in place. But which in traditional utility service methods, I couldn't even do today. We wouldn't be allowed to do something like that. So that's, that kind of indicates kind of where we are. But to bring it back to cybersecurity, how do I rely on that? Because if that control system fails, now you're lacking protection function. Now you're burning up wires. Now we have a real problem. And so that hopefully connects the dots with cybersecurity, and, because if we have critical control systems, so overcurrent protection systems that are, network controlled control systems, if those fail, then, we start burning things, lacking protection. So that's, sort of illustrates the seriousness, I hope, of cybersecurity, with moving on to the future world, which is going to involve these types of methods.
Question? Nope. Roland. Yep. I'll be right there. I got to leap. Leap here. Leap from Mike.
I did it. I think that was on video. All right. I'm Roland from Argonne. So I don't know. I hate to kind of be doom and gloom. So have we learned anything from like IoT cybersecurity that I feel like at an abstract level, we have a lot of the same problems here within the EVSE infrastructure. It took a while within like IoT before we started, I don't want to say regulating, but like taking security seriously. Like, what can they do? What is this? Like, what can a camera do? And then Mirai happened, and then lots of stuff got taken down, and it was taken seriously. I don't think we should be waiting for that, like in the EVSE world. And I think it's serious. And I think we're all here for a good reason. We all care about it. And we're all here on the second cybersecurity day. So we made it a little less than the first day, but we're here. Can we take lessons learned from that and maybe facilitate incorporating security? And I know, like, from a practitioner's perspective, there's probably that like seesaw of functionality versus security that you're doing. You want to enable cutting edge technology. However, there should probably be some semblance of security when you're integrating within heterogeneous complex infrastructure and affecting your neighbors. So kind of how do we, I guess, learn from our history and apply it to this emerging technology? And do you have thoughts about that?
Well, I have a lot of thoughts about that, but to can we learn or should we learn from IoT? Yes, absolutely. The same reason why we should learn from transportation and vehicle space and all that. What are the specific things we can learn? It's like, be prepared, be mature about what cybersecurity is. Don't assume you're invulnerable because you haven't been hacked yet. Follow best practices, develop best practices relevant to your industry. Do a security assessment of your product and then fix the findings, and work with and among your industry peers to develop ways to hold your suppliers accountable. You use the financial resources that you have to push risk. At any time, as far as I'm concerned, I've been starting to think more and more of cybersecurity as like the value-added tax. Like, you should basically, if you're a customer, you should be able to say, like, what is the security value add that you put on as part of your value to me? And that should be able to persist like all the way down the supply chain to the component level. So I think that is like maybe something novel we can do in this space a little bit. But I mean, the things I mentioned earlier are probably like maybe some of the easy things we can learn. Just be mature about it. It's not 1997. We know that malware exists. We know how it propagates. We know so much more about cybersecurity than we did even in like 2009, 2010, when all the CAN bus hacking started, really exploding. So let's look at EVSE and understand the protocols and integrations within that are complex multi-stakeholder barriers, right? And let's analyze that with the security lens that holds everyone accountable.
All right. Well, since I'm holding the microphone, I want to add an additional question to the panelists about this. We've heard today about other standards of cybersecurity with respect to DER. Thanks, Jennifer and Michael, with 2941, and even the approved product list. Thanks, Jordan and Brendan. With the NEVI requirements and whatnot. But are there any other industry sectors that aren't that are analogous that we can learn from to augment any standards that are forthcoming or in place, such like not engineering standards, but more like theft or security type of activities, where because the bad actors aren't playing by rules. They're not following a set of standards, where in engineering we do follow a set of standards, obviously. So do you know of any other industry segments that we can take a cue from or learn from, especially with years of experience, that we could apply to EV charging infrastructure, security, safety, cybersecurity aspects to augment solutions?
I think programmable controls, industrial controls, PLCs, I think, and it's because the problem started earlier. There was a Stuxnet virus that infected some, programmable logic controllers, and the net industry started taking it seriously and saying, we got to do something. And unfortunately, sometimes it takes an event like that to wake everybody up. And so I think that the manufacturers in that space have done a good job of building security into the products since then.
Yeah, I'll maybe plug some of that standards work that's going on at SAE in terms of like they're doing some interesting work around hardware security requirements and kind of standardizing how some of the security enabling technologies can be standardized across the industry, which I think is important. I think it's naive to assume that the types of hardware security modules we're going to find and the vendors of those products that we're going to find in the energy sector is going to be that different from the same players that are doing it in automotive. So I tend to look there. I think there's a lot to learn.
I have little experience in this area, so I can't speak too much about it, but I do get involved in contracting efforts. And as everybody knows, nothing is 100% secure. And so what we end up doing in contracting is we end up working out sort of risks and liabilities. And so, because if something happens, then, who's going to pay for it and what are you going to do? So these are terms that are laid out in contracts. But, if you go into those sections, there are limits of liability that are covered there. And so I think about, well, who's providing cybersecurity insurance to these firms? And I've never interacted with them, but if you're going to provide cybersecurity insurance to a firm, and these are pretty significant levels that are covered in these contracts. So I'm wondering, what are they doing to make sure that their clients are appropriate risks? And maybe it's worth engaging some of those firms. Like I said, I have no insight into who's providing this coverage, but I know they do it.
That's a great point. Thank you. I'm familiar ever so slightly with that with respect to ransomware, but that's a great point. Thank you. I hadn't thought of that. So are there any other questions? We still have just a few minutes left, weaning time, but
I don't have any question. I have a comment actually regarding your question at the program. I actually posted here. So GSA has a program called FedRAM certifications. And so GSA has a program called FedRAM certification, and they are very thorough. And that program is for EV charger, EV infrastructure program. And it takes almost probably 2 years actually from start to finish. They go through very formal process of evaluating the cloud infrastructure, charger, end-to-end perspective. And then they basically certify that your infrastructure is certified. Once it is certified, then you have to do audit and all those things on a quarterly basis, yearly basis. I don't know that part. We are not on that yet. They already certified that a couple of companies. ChargePoint is one of them, Charge is another one. And I do know that it's very expensive. It is time consuming, and it's not probably the small operators might not be able to afford to do that. And that's the concern, and they're aware of it. In fact, what they did, whatever their original process, they tailored it actually. And I think part of whatever they did, I think based on the input from Joint Office, if I'm not mistaken. And so they are working on it actually. And that program is very, very extensive, I can say actually. So that is not a bad program, and it is required for government agencies to, like if you want to do business with the government agency, then it is very much required to have that certification actually. So there is something there in place. At least I can say it's kind of two-way process as of now. It's like they are also learning because EV infrastructure is new to them also. So they started benchmarking like whatever they do for similar kind of industry. And then now they are learning and trying to add, modify and change. And I believe it will be evolving over a bit of time also.
It's good. We'll take a look at that. We'll do some benchmarking, the EV charging, cybersecurity gap analysis that I mentioned earlier that we're working on. I'll make sure that we do some benchmarking there and get the details.